Hello, this is question 11 on your November 2020 paper 2 from edexcel, and you have a modulus function. It's already represented for you, and this is the equation. And the vertex of the graph is at the point P, so this one here, and we have to find the coordinates of P. So if we have the function, this is very similar to a quadratic in complete the square form, because we have something that only can be 0 or positive, which means this whole thing, the minimum value that can take is when this is 0 and then I subtract minus 5, because otherwise this will be greater than 0, and when I subtract minus 5 it just will be greater than minus 5. So the minimum value is when this is 0, which is when x is minus 4 and y is going to be minus 5. So this point is the minus 4 minus 5. So that's the first part. P is x minus 4, y minus 5. That's A. So solve the equation. So we have our modulus function and then a straight line. So remember to solve these type of equations. What we are going to do is to take the positive version of this and the negative version, and then find the 2 points of intersection. This function here is a line. The y-intercept, it will be the 40. So I have a line doing this. Depending on the gradient of this line, I will have 2 points of intersection, but it could be that I have only one, which is the case of this one. So let me show you, because the gradient of this function is 3, of this straight line is 3, the gradient of my modulus function is 2. So my line here is going to be more vertical, if you want to think that way, than the modulus function. So it's going to meet here somewhere, and if you extend this, it will meet somewhere else. Yeah, and this point is not part of my modulus function, so it won't be a solution. But let's going to check that without thinking it in advance. So we are going to see how we can work that out without doing the sketch. So I have 3x plus 40, and the positive version of my modulus function is going to give me one solution, and then I'm going to do the negative version. So when I do that, I have 3x plus 40 is 2x plus 8 minus 5, which means that x is going to be 8 minus 5, 3, and minus 40 minus 37. So this is one solution. Let's going to check what happens with this solution. To see if it's a solution for this equation, I'm going to substitute in the left-hand side and compare with the right-hand side. So in the left-hand side, I have minus 37 times 3 plus 40, which is minus 71. And the right-hand side, if I substitute here the minus 37, I have minus 37 plus 4 is minus 33, absolute value of that is 33, and then I do 33 times 2 minus 5, and that's 61, positive 61. So it's not the same, which means that this is not one solution. Yeah, it's going to be this point here that I mentioned in the sketch, and you don't need to do the sketch or it's just for you to understand what's happening and why this is not a solution. Yeah. The other version is the same, but with this negative. So I'm going to do the same equation, but with that value negative. So 3x minus 4, and I'm going to put the minus at the front. X plus 4 plus minus 5. Minus 5. And I'm going to solve this equation now. So 3x minus 4 is minus 2x minus 8 minus 5. So I have 5x is going to be... this is 40, no? 3x minus 4. This is 3x plus 40. Sorry, this is plus 40 and plus 40. So I have minus 40 minus 8 minus 5, which is minus 53. So this answer here would be x is minus 53 fifths, or minus 10.6. And now we are going to do the same checking that we did with the other one to see if it satisfied the equation when we have the absolute value here. So in the left-hand side, I have 3 times minus 10.6 plus 40, which is 41 over 5. And we are going to check if that's the same here. So I have minus 10.6 plus 4, absolute value of that, times by 2 and minus 4. And this is 41/5. So this one is the solution that we are looking for, and it's this solution here. Yeah. Then a line has equation y equals ax, where a is a constant. And given that L intersects at least once, find the possible values of A, the range of possible values of A. So let's going to think a bit what that line is. So that line, y equals ax, is a line that passes the 0, 0. Yeah? So it will be a line somewhere passing the 0, 0. If I want a line to cut twice, that means, so if I have a line with the same gradient that my modulus function, so well, it doesn't look completely parallel, but please think that it's completely parallel. Yeah. So if my gradient of this line is 2, so if a is 2, these lines would meet at any point. Yeah. But if you consider the line that passes this point here, so touching the vertex, and passing the origin, so let's say that is touching the vertex and the origin, this line is going to cut in one point. When this gradient decreases, so when it goes this way, this line will cut my function twice. Yeah, up to here, because here it won't touch any point. So anything smaller than, so if I move that way, I have gradient smaller than the gradient of this line, and we can find it. Yeah, it's easy to find. And when I move this line, so if I increase the gradient, even if it doesn't look like, this one is not parallel anymore, so it will cut this line at least in one point. So if I move that way, and I have that a is greater than 2, it will meet the line at least in one point. Yeah, so anything that is a greater than 2 will meet the line at least once. Anything that is smaller than this gradient will meet the line at least once. So let's going to find this gradient. This gradient is the gradient of this line. We know this point, and we know the 0, 0. So the gradient of this line, the gradient of that line is going to be the change in y. So it passed the point p minus 4 minus 5 and the origin. Yeah, so the gradient of the line is going to be 5/4. Yeah, or minus 5 minus 0 minus 4 minus 0. So that means that a, or the line, is going to cut if a is smaller than 5/4 or a is greater than 2. Yeah, we have to write our answer in set notation, right? So we are going to write the brackets. We are going to say that a must be smaller than 5/4, and it could be equal because then it will cut in one point in the corner, or so union a must be greater than 2, and it cannot be 2 because if it's 2, it's completely parallel and it won't cut in one point. Yeah, so that's my answer.